taking an IoT device out of the box, plugging it in, and then I expect as a consumer it should send its data to the backend and I will see everything. But how does this work? How can this be made secure? How does this device connect to the cloud? Where does it know which server it is? Does it know which credentials it should take? There are keys involved normally, and they are stored on secure elements on the hardware. And in this webinar, I will explain you what keys you might need, who should bring these credentials inside of the device, how to store them hacker-proof, and so on. And also, one important thing is, how does the cloud know that the new device may connect to it, but the hacker may not? These topics I will explain in the webinar, Zero Touch and Onboarding. Enjoy. Yeah, I'm glad that you joined us for this first self-owned, self-hosted webinar of OSB Connective. I want to do some expectation management that normally I do in talks that we're not talking about different things and have like maybe that we are in line in our expectations. So what I want to give you is a security overview of many security aspects, and one of them also is the whole topic key management, provisioning, onboarding, and that's mainly in the focus, or that is something that you want to have if your POC was okay, and now you want to go to serious production. And then many things need to be automated and secure, and this talk will tell you a little bit about these things that you have to do. I will not show coding examples or like how you would really implement this in AWS, Azure, and so on. So it's more about the technology that you need, the steps that you need to go forward, but not about how exactly it's behaving. I just show some schematics, how it's done. And my goal for this is that I raise awareness for many security topics in you, that you will not go to some problems that might be mitigated by maybe more knowledge. So this is one of our things that we do normally with all our customers. And the topic zero touch provisioning is for sure also shown with a little example at the end. Yeah, so you can hopefully understand it a little bit better. Maybe you've heard zero touch, maybe not. I will quickly explain roughly what it is. So here you see, so this will be the device lifecycle later, and here you see the usage time when an IoT device, which could be a refrigerator that's sending telemetry, it could be a car, could be a tractor, could be actually anything, power meter, and this is transmitting data to a data platform, maybe of the OEM or to some other platforms, on-premise, cloud, whatever, does not matter. So this is actually the use scenario of your IoT device. At some point in time, your device will need to be produced. That's for sure. You need the hardware. And at some point in time, this might be new. The device should also be decommissioned, which means you would want maybe to wipe some privacy-related data from the device before it's going to the trash, or you might want to make sure that the keys that are on the device that let the device into the cloud platforms, that they are wiped and deleted as well. So this is called decommissioning. Another thing that might not be obvious and not the real use case of your customer or maybe of yourself, or what you want to do with this IoT device, is the things that you do with a device management platform. So this could be remote maintenance and access to the device so that you can debug problems. You want to maybe also upsell some features. Maybe you sell a cheap version of your product, but then later can sell digital features. So maybe using an application that is in the image, but it's maybe only not allowed to the customer. And for security, you will definitely need to have a way to update the operating system and also your applications, because they might have vulnerabilities that need to be fixed. And in order that this is working, so that this green scenario is working, the device needs to know, okay, which is my device management system, which is my data platform system, what URL is it, and how can I get into that system? And this is the two things like provisioning and onboarding. So onboarding is more with respect to the server backend. So also the servers need to know about the device, and the provisioning means more or less that also the device knows which server it should communicate to. And this is zero touch, actually. That's the idea, to have this gray things here that have them automated as far as possible. So no touch needed, everything's working automatically. And that's what this presentation will be about. First, I will give you an introduction also into some security things, some threats, and also some regulation things that are going on. We will have a look into the life cycle of connected devices a little bit deeper with some more aspects of it. We will talk definitely about this topic, provisioning and zero touch. What is it? What's the definition? How it's working? And with examples, I can show you how this would work with a device management system or in your products. But first of all, allow me a quick introduction into OSP Connective. So mainly we have two business units, and we have a background with our team and our products of more than 20 years now. Mainly we started in digitalization of agricultural industry, so both communication and the standard design and standards that are defined there. So we collaborate with the standards, we implement this, and we enable the customers to communicate over these standardized buses in the agricultural world, and also, for example, communicate to farm management systems and such things. And a rather new topic for us is the topic embedded security and IoT. So we started this in 2018, and I am the leader and the product manager for this whole business unit. In this the yellow colored picture, our business unit, the mission is that we protect and manage connected devices all over the world, and we protect them against any kind of cyber threat that exists there. And how can we do that? So normally we do things like consulting, training. We help customers with their projects in the beginning, in the initial phase, to tell what security requirements they have, how they should implement this, what to do actually. So it's more in the beginning of an IoT project. And at the end, we can also offer solutions that keep these devices up and running. For example, doing software updates, doing communication, all these things, we have a solution, but that's not the topic for the talk today. We have several partners. So our partners are in hardware partners that provide many individual or tailored devices that suit a certain industry. For example, agricultural industry with BH-Tronic. This is where we did our first big project in 2019. And currently this is rolled out all over the world. But we have plenty of other boards that we can run on our software on. We have different partners where we made projects with different scopes, and we have partners from software, from hardware industry, from service providers, as well as from connectivity services like WhereverSim and others. And our technology stack is also quite big. So we go from the embedded things that you can have there, from Yocto and build-root Linuxes and so on. So really from how to do embedded Linux on a device, over software update mechanisms that mainly are open source. So we try to use open source where possible, but also up to the cloud platforms, Azure and AWS, for example. That's our technology overview, but our strength and our focus is more on the embedded side, which is something that not many service providers have in mind. Many companies do IT security, but not so much embedded security. Why am I talking about security at all? So security is needed. I know that, but not many people, I think, at least feel obliged to do that as well. And now the EU has some regulations going on. So one will be coming next year or the year after that. That is called the Radio Equipment Directive, and it's targeting on devices that have a communication radio somehow, or a radio for detecting things. They need to have cybersecurity implemented very soon. So next year or the year after that. So this is still in discussion, but something bigger is coming up. So for the next 3 or 4 years, it's called the Cyber Resilience Act. And this focuses on all products with digital elements. And that's nowadays nearly everything. But what security is the European Union proposing here? So the important thing is that it's not only targeting the product itself, but it's also targeting the development process in your company. So it says that during planning, design, development, production, delivery, and maintenance of your device, cybersecurity risks should be looked at and should be also documented. So this is new, and also just one example. So there are many things that I could talk about that, but one example is also that you are that you need to provide software updates to fix vulnerabilities within the lifetime of your product. And if we talk about tractors or if we talk about an escalator, these things are really long living, and it's a struggle to find also a vendor that can guarantee that he gives you 10, 15 years of Linux updates. So these things they come soon, and just if you're not aware of that, so this might be one topic where we can also talk about, and we'll also maybe have some webinars in the near future. But from this like regulatory motivation, I would call it, let's go to some attacks. So what could happen on such an embedded device? And these are only two examples that I would like to present to you. Generally, we have this blue box. This is your embedded device. It has an ID 1234. And it has some application that sends data to a backend. And to do that, it needs to have some authentication. It's telling the backend, hey, I'm device 1234, and I have this key. Please let me in. Please accept my data. What could an attacker do here? So actually, one attack could be that somebody tries to steal the key and copy it. So copy it on his own computer, for example, or may make even a cloned device. But I think already that I put it on my computer is quite a good attack, because then I can take this key and I can say I am device 1234. Please take my data backend, and the backend will not have a way. It cannot figure out whether this is me, the attacker, or whether it's the device itself. So this is really a problem. And if, for example, you would identify that there are many devices coming in with many different IPs, for example, maybe you would want to shut this device down. This device not allow to talk to your backend anymore. And then actually this would lead to a denial of service. So you will not be able to service your machines anymore because you are not trusting its credentials anymore. So actually you lose connectivity with this device, or you should lose connectivity. Yeah, one of the possible solutions here is that you just prevent the copying action. So you have to store the keys in a way that they cannot be copied, and there are at least many technical ways how you can come very close to that. So everything's possible in security, but to make it really hard, there are easy solutions. And also what you could do is you could renew these keys from time to time and limit the lifespan of each individual key. So this is also one best practice that you can do for these situations. Another thing is, like I said before, maybe you sell a product that has 10 applications, or maybe 3 applications. We also will have an example like that later, but only 2 of these applications have been bought by your customer. The third application maybe does not need it. Yeah, so you sell the product a little bit cheaper, and give him a license key that he can use application 1 and application 2, for example. But let's say your customer has bought one device, got all the licenses for this one device, but he has 100 devices at his place. And maybe he wants to have this license activation for all these other devices. So would he be able to copy this license file that you deployed over the air to the device and maybe manipulate a little bit, put it on the other devices, and would this run then? So this is a question. Could you get, for example, extra horsepowers, or this is, for example, called chipping? Yeah, but the chipping is really like a physical thing. So here, but can you like upgrade the other devices just by copying and manipulating these license keys? And that definitely should not be possible. And so we have to protect these individual licenses. The license need to have this ID imprinted somehow. They should be protected with a signature from a back end, and the signature should be checked by the application. So then you can really say, okay, my device only works for device 1234, but on device 6666, I will not work. And that's all, just one of the examples where you would have some potential risks also to your business cases, and where you should do something against that. This now is a big bouquet of different security requirements for embedded systems. First of all, we start with the integrity of the platform. So if the integrity means that I, as an attacker, would not be able to manipulate the software that's running on this machine. For example, this license checking mechanism. If the license checking mechanism can be changed by just doing some change to the binary, for example, then no matter what what license I give it, it will always be true, and I will always have all the licenses that I want. So I have to prevent that this is possible, that somebody changes my software. Counterfeiting and spoofing protection, this is what I just said. So we have to prevent the keys from being copied. All the keys, all the credentials should be unique for IoT devices. This is also new if you have a connected device normally. So talking to the backend, then this is a must-have requirement. You cannot just say every device is completely unique, completely similar to the others. Not possible. Automated registration and onboarding, that's actually what we will talk about later. Feature activation and then sending configs to a device is something that should be possible. You want to have reliable software updates that have fallback mechanisms if they happen in the field. So if something is going wrong, maybe you have a bug in your software, then this should not make the device inoperative. And for some events, you might want to have some secure remote access to the devices. If you have privacy data on the device and you store it somehow, then it must be protected. Also, like mainly for confidentiality, so that it cannot be taken out and read by somebody else. So you need encryption here, and for encryption you also need keys that you might need to manage that. And also you want to monitor whether the device is healthy and is secure, whether somebody is trying to hack the device or not, and everything should be also working at scale. So it should work for 10 devices, like for your POC, but it should as well work for 100 or 10,000 or whatever many devices that you want. And we will focus now on this right side here. So this credential thing, the keys thing, the onboarding thing, this will be major topic of my talk. At the beginning, I already showed something like the life cycle, so from production to the use and the decommissioning. But actually, there's something more to that. So the device lifecycle starts with not the production, but the device lifecycle starts with the design of the product and of the whole connectivity solution that you plan. So you have a strategy, you want to reach a certain goal, you want to give something to your customers, you derive security architecture, you implement that, you will need to test that if the implementation works. And then this horizontal line, this is actually what would be normally the production processes. Yeah, so hardware production, but also maybe flashing and then putting individual things on the device. Then the device is shipped normally for at least one time, so maybe from tier maybe 2 to tier 1, and maybe put to some other device, and then at the end it's at the OEM, or maybe it's only shipped once, and then the device is used. And in this usage, you will need to operate and maintain the device, like we said before, software updates at least, but also maybe some other things like remote access, feature upgrades, and so on. So actually, how would you start? So if you design your product now, maybe you already know what the customer wants, but like, what do you have to take care in terms of security? What do you need to do? And first thing is that you need to see, so in the design and development phase, what assets do I have in my device? What are actually the things that I should protect, and how should I protect them? So there's CIA, confidentiality, integrity, and authenticity normally. So these are the basic security goals. Also, availability of a system might also be needed for certain things. So actually you go and see, okay, what do I have in my system? I have firmware. Yeah, and here in this example, I&A means integrity and authenticity. So it should be not alterable, not changeable, and it should also be authentic, like really from the OEM. Yeah? And if it's changed, then I don't run again. So this would be secure boot, for example. Whether it's confidential or not, can be decided, but by default, INA would be enough for firmware. Credentials to log in somewhere, they should be confidential. So nobody should be able to see them and also not to take them out. Configurations, you can say, okay, maybe somebody can see it, does not matter, as long as they are not altered, for example. Privacy data is normally confidential and so on. Yeah, and then you, from these assets, you derive, okay, what can I do to protect this? So do I need, or will I need secure boot and maybe encryption on my flash and so on? All these things are important. Vulnerability management is a must. So this is also one of the general requirements of the EU regulations. They say you need to be able to fix security vulnerabilities timely. And timely does not mean 1 year. That's too long. So if it's critical, it must be quicker. And I would say, so depending on the product and the real risk that this product is posing to people, it will be much shorter than 1 year. Yeah, file storage, key encryption. Yeah, for example, key storage. This is one important topic. So how can you store these keys? So there's normally flash, which is not a good option to store the keys. There are certain hardware chips that you can bring on the device. They will store this private, for example, for asymmetric cryptography, they will store the private keys in a certain flash area where they cannot be taken out, only used inside of that small device. So this is stored really good. But what you take depends on the customer needs and also at the end a little bit on the price. So after you have had your requirements and you know what to do, then you need to produce the device. And here, yeah, you need also to prepare something. So first thing is like system hardening. This means that all the interfaces that you need, for example, for flashing, yeah, or for diagnosis in the development phase, they should be disabled in the production latest. Yeah, or secure boot needs to be activated at some point in time. So this is something that you normally do in production. And also, what else do you need to prepare? So you need to bring software to the device or files or configurations. But here the issue is firmware is not unique. So this is the same firmware maybe for every device, no matter which customer. But the credentials, as I said before, they will be, or they should be unique for every device and also for every customer. So this is something that normally in production, you don't really know. Yeah? So you don't know what configuration you should write in the flash, for example, that this device can communicate to something. So this is one issue. So ideally, you would just put on some credentials and later the rest. And that's actually the idea also of Zero Trust. So we put on this device a key that can talk to the device management system, and later the device management system can do the rest. And some things that you have to consider in this operational phase. So one thing is called onboarding. So in onboarding, you tell the servers that the device reports to, hey, there's a new device coming. It has this name, this ID. Please let it in. Give me a token for it. Also, like, yeah, if you want to activate a license and all these things, or if you have ownership topics. So maybe the device goes from tier to an OEM and maybe to the end customer. Now the end customer should see the data that is on this or that is sent by the device. All these things need to be handled somehow. And this is part for the operational phase. During maintenance, you will need to provide software updates. And so as a manufacturer, the minimum is that you provide the software updates on your website, and then the customers need to install it. But if you really manage this system, then you also should have a way to update the devices over the air. And there are many other things that you also should consider, like, for example, intrusion detection or prevention systems, certificate rollout, so that like having short-lived certificates that need to be renewed from every now and then. Yeah, CVE monitoring to check what kind of things you have in your software and whether they are still secure or not, or whether there have been some vulnerabilities found. And at the end, this ends in vulnerability management and patch management so that you fix all these vulnerabilities. The topic Zero Touch is mainly related here. So it's the things that the glue between the production and the actual use. So what can you do in the production without knowing what is the end customer, and but how can you still use and operate the device without much later rework? And yeah, so here maybe a little bit of definition about what I would say what provisioning means for me. So you have an ECU, and this ECU needs to have some keys. So this first step is called key management, key provisioning. And normally these keys are generated on board. So they are not taken or generated by a backend and then brought to the device, but they are generated inside of the device. And then for this special key, you can create a certificate. And only with this certificate, the endpoints normally will let you in. Yeah, so this is like the passport that the device can show and say, hey, I'm device 123. I am authorized because, and this is what you see here, this PKI database, that's actually an entity that can sign and give me a signature to my certificate. I will not go into details here, so this is also a topic of its own. But at the end, the PKI is something that my company owns. So your company, my company, and then you let this end device certificate be signed by this PKI, and then you have keys and certificates on the device. You store them securely, and then this key provisioning topic is over. And then the second thing is the onboarding to the servers, to the endpoints. And so this is like two steps. So one thing is the servers need to know that there's a new device coming and yeah, create an entity on the server and so on. And the other thing is that the device has a configuration that it knows, okay, what's the exact URL where I should talk to? Because, for example, Azure or AWS, it's all in their system, but each customer has an individual dynamic part in the URL that's the count ID, for example, and this needs to be known by the device. And so this configuration also needs to go down to the device. And then at the end, I would say, okay, if both of these things happened, then the provisioning is done. Let's have a look at this in a like timely manner. So we have ECU, yeah, then we have electricity and internet, and then something happens, and at the end I have the device provision. So that would be the goal, yeah. So that everything will be ready after I just give power and internet communication to the device. How can I do that? And before I will show you like a sequence diagram of how this could look like, let's quickly jump into what is actually on this embedded device. So what is the software and the configuration files that will be placed there? You see here, so on the left side, there will be the like general software parts. So everything that is shared among all IoT devices that is not really specific. Yeah, so there is kernel, library, services in your operating system, and this is in all of the devices. It's all the same. And you have FOTA, so firmware over the air or software over the air client, and you have a remote access client, for example, SSH or VPN. And here we start already. So these two services already need to have an individual configuration to know, hey, what is my software update server? Where should I create my VPN tunnel to? Or what access rights should, or what password should this like SSH login have? So this should be individual per device. And here we have the first device individual configurations. A second thing might be the applications. Like in the example before, you have 3 applications, only 2 have been bought by the customer. The third application should be sleeping all the time. So actually you need to have 2 license files and maybe some configuration that is on the application level and then enables your application to work or maybe not. And what you also will have maybe one or multiple times is some, I call them cloud connectors or backend connectors. So this is actually the real application that sends data somewhere. Send data to Azure, AWS, to your backend, to your dashboard. And all these single applications normally need a new individual URL, ID, and some reference to a key slot if it's a hardware key or maybe a token or something else. And then we have also this, what I said before, this secure key storage. It's actually not shared with all the other devices, even if it's on the left side here. So this is also individual, and this is normally always some key. There are like several key slots on such a hardware storage, and with each key slot you also would have a certificate, and that can be later used to log in to the backends. So that's actually what we would have on the provisioned device at the end. So these things. But when is what, or when can we provide what of these parts to the device? So if we go back to see our lifecycle or secure engineering flow, then you see, okay, keys and certificates are actually, mainly the keys should be done somehow in the production normally. And then the applications, they can be flashed. So like the initial image, so the initial Linux image normally can also be flashed in the production. That's not a problem. Yeah, credentials could be done in the production, but then you need to know like what is the end customer, what are the servers, because only then you can place some credentials there, as well as only then you would know, so you can do this only if you know what is the software update server, for example. So mainly these dotted lines are not really practical because you don't know many of these things. You don't know the software update server in the production line. So the idea is to do this OTA, so over the air, and that can be done. Yeah? But what you see here is the keys and the certificates, they still stay in this area here. So they are somehow in the production process, but everything else, so like credentials, so this would be like a root password, for example. These things, they can be sent over the air to the device and can be configured when the device is at the customer side. And that would be what we want. So key management is needed very early. So you cannot create keys on a device that is at a customer side. Yeah, so then you would have, actually you don't have a real trust anchor that you can rely on. Maybe your customer tells you, hey, I've created this private key and the certificate, please give me a certificate for it, but actually that you might not want to trust them. Yeah, so if you do this one thing first, then you can do all the other things at the end. And that's the benefit of this whole device management and of these automations. So now we come to an example, but unfortunately, it's not an example where you can see something live on an embedded device, but it's more like the flow of how this would work. So the blue thing is our device. And you have to think of this like it's, for example, a Raspberry Pi with a vanilla operating system that you just put on an SD card and it's running in there. And you have a TPM or some kind of other secure storage that you place also somewhere else. Yeah? So this can be like a Raspberry Pi situation, but also like your device where everything is integrated on one PCB. And then there's a function that is used to self-configure the device. What it does is it communicates to the key storage, so it's SPI or I2C communication, and it's asking, please give me the certificate so that I know what is my name, yeah, because the device does not know its own name before that. And then it's communicating to the device management. So this is one of the URLs which the device should know, and this should be part, so the URL of the device management should be part of the embedded system as well. And it's telling, hey, I'm device 123. And then the device management might ask, hey, but can you prove that somehow? And yes, I can, because I have a certificate, I can show you that, and I can also do some mathematical calculations with my private key. And this is actually the proof that tells the device management, okay, this seems to be plausible. And if I know that these certificates are only created for devices that have a hardware security storage, then I can say, okay, this seems to be trusted. What happens next? The device management will have a deeper look into the certificate. And if the certificate is part of the PKI infrastructure, so, and also here's like why I would need a PKI for this setup. So there are other setups possible, but for this setup, I would need the PKI, and it checks, okay, it's authentic, it's part of the of my PKI structure, so I trust it. And then yeah, okay, then there's something that's also missing. You need to have that because no automation can work without any information. you need to know what serial numbers have been sold to what customer. And maybe for each customer, you have some kind of a routine that tells, okay, for this customer, I always do that software, that backend platform, and so on. So these things, they need to be known. It's not pointed out here in the picture, so I hope that you still get it. So this is kind of a lookup table that you need to have. Maybe your customer management system that tells which orders the customer has placed, and then you know that serial number has been sold to that customer. And then the device management is communicating to all these customer platforms for the data platforms, saying, hey, there's a new device, please give me the credentials. It's receiving those. It creates the configuration files. It deploys these configuration files over the air to the embedded device. And then actually we have this configuration ready. Yeah, so we already have the key, like we've seen before. So we have keys and certificates, but they have been there before. And now we also have the configurations for all the services. And next, after we know that, and after we already have sent, for example, the software update server configuration to the device, we can even then do software updates and maybe load the real software that is nearly free of all the vulnerabilities, that has the newest applications and so on. And we can deploy that also over the air at the site of the customer maybe. And then we're done. So this is actually the ideal scenario that we would like to have. Yeah? Give power and electricity to the device. Then the device will self-configure here. It will self-onboard on the management system. So also the management system, there are some automations that you need to do here. You go to all the backend services, you get the credentials, and you create configurations for them. You also do a software update, and then you have the device with the newest software and with all the configuration that it needs. And it worked because you had this lookup table, because you have this PKI infrastructure, and because you have the key already brought to the device. Next example would be, okay, but how do the keys get on the device? So this is actually a special topic because you don't want to do this where these keys could be, for example, duplicated maybe in the production already. So attacks can happen everywhere and every time. So they can happen if the device is in the field, but they can also happen during production. So how do you have a secure production facility, or do you maybe do this overseas and you don't really actually know what's happening there? Yeah? So there's some solution for that as well. And if you don't want to do this on your own. Then there is one thing that we did also for a customer, that we go for a service provider, and also like all big distributors offer such kind of services. These service providers, they have a so-called provisioning HSM, so it's a secure storage as well. And into this provisioning HSM, I transfer a private key and a certificate from my PKI. So actually, I make them to a signing authority, a certification of authority, CA. Yeah, and this HSM is handed over to the service partner. Then the service partner is talking to a small chip. So these are actually the chips that store the keys, and they later will be placed on my PCB. So they pick it from the real, put it into provisioning machine or something like this. They say, okay, create a key. So they communicate with the device, they create the keys. After that, they create a certificate signing request, CSR. They forward this to the provisioning HSM, and there it can be signed with our PKI, or like if it is in our PKI, so it's signed by this certification authority. And then this certificate is also placed on a general purpose storage, also on this chip. And then you have a cool thing. You have chips with certain amount of keys, and also with the certificates that are aligned with these keys. And all of them are within our PKI. And this I can just put on the PCB, have the standard software, and then I can do this same workflow like I said before. So the device is self-configuration, configuring itself, and then I can do all the magic that I want to do. So the benefit here is, you don't need to handle the keys. You don't need to look for randomness of these keys. So it's easy to handle. There are only a few disadvantages. So one is that normally you can only do this in ranges of 1,000 to 5,000 devices. So you cannot have a batch of 10 devices provisioned in this way. So for POC, it's not really good. And also another problem is that the serial number of your PCB and the serial number of your certificate, they are not really aligned. So they are both random, and then they are soldered on the device, and then at the end you need to somehow map them. But that's also doable and kind of easy. So what I've talked about right now is this part here. So it's called just-in-time registration. Yeah, so there we use a PKI, some provisioning HSM at the, for example, at the service provider, and then I have some certificates. And because this certificate is part of the PKI, the backend trusts it, and so on and so on and so on. All these other things can happen. But there are also some other ways what you can do. The major benefit of this PKI stuff is that you can do this offline. So you don't need to have internet access in the production facility normally. There's also the just-in-time provisioning. So there it's a little bit different. You don't, and the good thing is you don't need a PKI. PKI is tricky. It has some tricky revocation problems. Maybe we can talk about that in the question round or in a separate talk. But let's just leave it like that. The just-in-time provisioning means that you have some kind of a registry service or registration service. You create also the key inside of this chip. You also generate a signing request, but this is not signed offline, but the signing request is sent to the backend. Then the backend will say, okay, let's have a look. And this provisioning tool that I have here, so this also has a key that just can be used to transfer this signing request to the registry, and then afterwards it will fetch this signed certificate and then also put it on the device. So it's similar, but here the end device certificate is not part of this PKI structure at all. But also I don't need that later for my automations because it's already registered. Yeah, so that's the trick here. So in this one phase, the device is registering itself somehow. It's not known before. And in this second thing, like just-in-time provisioning, then I give the certificate to the device just in time, and also the registry knows the device at that moment. And then there are also like batch provisioning options where you generate keys and you generate certificates normally. You get the batch of these things to your computer or whatever, and then you inject these keys into your secure storages, for example. But that's generally less secure because the keys have to be handled somehow. Maybe they are part of some IT system, maybe they get stolen there. So this is possible. It's easy. It's very easy. Yeah, but it's not so secure. So be careful if you choose this. And yeah, that brings me to the summary, to the takeaways. So I hope that you could follow the general idea and the challenges of this whole onboarding scenarios. We've seen some attacks at least, and I've hopefully made clear that in the EU regulations there will be many things coming up for all digital products. And it takes time also to bring this into your new designs and into the existing designs. Provisioning can be done over the air. That's I think that should be the goal for every project. So you should be able to do that later. But in order to do so, you have to now think of, okay, but how do I handle these keys? Because this is something that you cannot do over the air. Partnering benefits, yeah, of course. So IoT is never done alone. It's helpful if you know what you need, if you know what your requirements are. You can save a lot of time taking components that are existing. And yeah, but I think that's more or less clear. Security and provisioning concepts and tools, yeah. So we've seen that many things can even be outsourced. So there are multiple ways how to do this key management. And also one example, what I've shown here. So all these things work for sure with our IoT suite, and we tell you what you need to do so that you can use all these automations. Thanks for watching the webinar. Please subscribe below if you want to see more videos about embedded security and IoT security. We are constantly creating and recording webinars, tutorials, and so on. So please subscribe to our channel.
Also, if you have any comments, questions, feedback, feel free to put it in the comment section or write us an email. Thanks for watching.